Everyone, welcome back to the channel. In this video, we are solving Leetcode problem 38, count and say, and we will use Java as a programming language. And so let's understand the count and say sequence problem, right? And understand the statement, then we'll go through the example. The question statement is saying that the count and say sequence is a sequence of digit string and which is defined by a recursive formula, and these are the recursive formula we have given. So if you pass the count and say a function as 1, you will get the string 1, and if you pass the count and say n is the run length encoding of count and say n minus 1. Okay, what is run length encoding? So run length encoding, RLE in short, is a string compression method that works by replacing consecutive identical characters, okay, which is repeated two or more times, you can say, with the concatenation of character and the number making the count of characters length of the run. For example, to compress the string this, we will replace 33 with 23, and we will replace 222 by 32, and replace 5 with 15, and replace 1 by 11. So thus the compression string becomes like this. So we have given a positive integer n, and we will return the nth element of count and say sequence, right? So we have to return the nth element of count and say sequence, okay, for the positive integer n. So if you go through the brief of this statement, right, and if you pause this video, if you read 2 or 3 times, right, it will better to understand the concept, the problem statement, right? And so the question is saying that the count and say sequence is a series of digit string, right, where each term is a description of previous term using the RLE, right, run length encoding, right? So for example, let's suppose if we have count and say is 1, right? So what will happen? We'll get the output as 1 in double quote, right, as a string. If you say count and say 2, right, so there is a RLE, right, of this 1, it will become what? 1 1, right? So it will become 1 1. If you say count of 3, right, it will become RLE of double 1 is 2 1. Got it? Means 2 in this it is 1s, 1 and 1s, right? Now you are getting what? 2 1s. Now you are getting what? 2 1 2 and 1 1, we can say, right? So we need to write a count and say int function that will return the nth term in the sequence, right? So I think you understand this problem, right? But you just understand the intuition, what is the program intuition is saying, right? The statement intuition is saying, right? So let's break down the intuition behind and this count and say problem, right? In a simple terms, we can say, or you can ask yourself, what is the intuition behind the count and say problem, right? If you have paused this video, if you read this question, right, that will be better for you, because if you do that, then you will understand the intuition behind the count and say statement, what is saying it, right? So imagine reading out loud, okay? So the digits of number in terms of how many times each digit appears consecutively, right? If you pause this video and if you see this example, right, then you will clearly understand what is saying that if you pass 1, you will get 1. If you pass 2, you will get what 2s. If you pass 3, you will get what 2 2 s, right? Like that you can say that, right? 1 2 1s 2 1s, and like that we can say, right? We can say that. So we say, let's suppose we say we have a string 2 1, right, and we don't read it as a 2 1, right? Literally we can read as what we can say 2 1 then 1 1, means it will come like this. Let's go with this. I will explain here. So let's suppose if you write in double string 2 1, right? So if we say the string is 2 1, right, we don't read it as 2 1. literally instead of this, what we should read, we should say, instead of reading the 2 1, right, we can say, we can describe like what we see. Let's suppose 2 1, then we can say 1 2 1 2, then 1 1. Means, just focus what I'm trying to say, right? We have a string, this 2 1, we have this string 2 1, right? And give me one second, we have this string 2 1, right? So we don't read it as 2 1, right? Means we don't want to read as 2 1. What we want to read? So literally, instead of, we describe what we see, right? And so we can say 2 1 2. There is 1 2, then 1 1. Means there is 1 2 and then 1 1, right? Means what we see, right? So each term in this sequence is a description of digits in the previous term. I think you understand now, right? So each term in the sequence is a description of the digit in the previous term, right? So people will say 1 2 is there and there is 1 1, right? So you can speak like that, and not to say 2 1. Why we will say 2 1? No, we will describe it. What we see, that we will describe it. Okay, think of it. I think we have the example here, right? So as you can see, for this example, right, what we have here, so there is 1 1, we can say 1 1 is there, right? Then we can say what we have here, we have 1 1, I see 1 1, right? If you talk about this one, we will say what? 2 1 s, 2 1 s, right? Then what we will see for this one, we will say 1 2, then 1 1, right? 1 2, then 1 1, and so on. So this is a recursive in nature, because to get the count and say, you must first say count n minus 1, right? As you can see here, right, to find this, because this is called recursive formula, right? So you just think about it and say this is a recursive in nature, because to get the recursive count of n, you must first say count n minus 1. Got it? So the key pattern here to observe is that, like, it's not a math based, right, but it a pattern recognition, right? You don't need to you need to go to identical consecutive digits and not to the math based, right? You need to go group identical consecutives, right? You have to go group consecutive identical, right? And then you can say the say count followed by the digit itself. So you use this a spoken version of the next input, right? So this is a simple form of compression, you can say. And there should be a group, similar characters will be together, and count how many times they occur in a row, and the output will be the count followed by the character, right? So let's suppose if there is triple one will be there, right? So we will say what? 3 ones. We directly will say, if there will be like this, let's suppose if there will be in the string, so let's suppose triple one will be there, right? So what we will say? So we will say 3 1. Why I am putting this? There will be 3 1, right? We can say 3 1. And how will you speak it? Like, we'll say 3 ones, right? Like this. But for this problem, it always apply consecutively from the previous result. So there should be consecutive, same elements should be there, same character should be there, right? So why the recursion works well here, right? Because you don't need all n terms at once. You just need the previous term to construct the current one. So if you'll talk about this one, right, or anyone, right, so you just need the previous term to construct the current one, right? And so you are saying 3 1, right? 3 ones, right? So if in short, if you want to say me about this problem, right, this is a look and say problem, not the count and say, right? Because each terms tells the story of the previous term digits, and you are just the narrator saying out loud with the counts, right? So we can say this problem is not the count and say. We can say the problem is, so the problem is a look and say problem, not the count and say, right? So you have to think, you have to read, and you have to understand what the problem is saying, because once you understand these examples, right, then you will say, okay, so this problem is not saying as a count and say. This problem is saying that this is a look and say problem, right? So each term, the story of the previous term's digits, you are just a narrator, just you are saying that loud with the counts, right? So let me go through the step by step so you will understand here, right? Okay, so there will be there are some steps I have created here, right? So you will understand one by one, and then we'll write the things in the steps, right? So let's understand from the step one. So in the base case, we have taken what? If n equal to 1, we will return 1. So this is the starting point of the sequence, right? So we will take base case. If n equal to 1, we will just return 1, right? Then we will do recursively get the previous terms. How will get? To get the current one, you will say count and say n minus 1, you will get the previous one, right? To get the previous one, you have to make it n minus 1, right? So recursively we will get the previous term using this. Then in the step 3, we will take a string builder for the efficient string manipulations, or you can say we will traverse through the previous term and will count the repeatedly the digits. We will count the repeated digits, you can say, and we'll count the new term using the count plus digits, right? So we will do traversing next, and in this loop what we will do, we'll get the element each time. We will run here actually we are doing what? The run length encoding, right? So what we are doing, we are getting the current character. You have the previous character, right? So previous character at I, you will get the current character. This will be your count. In the loop, what we will do, count the occurrence of the current character. We'll check the occurrence, then we'll increase the count, and then we'll append the string builder, right? And what we will do, we'll return the string, right? And finally, once this is done, right, you will return it as a output because it is taking in the string form. And so this is the way we will implement, right? So what we are doing actually here, so if you'll talk about the complete whole program, right, what is doing, so we can say we solve the count and say problem using recursive and run length encoding, because in this way we will uh, implement recursively. We will take the base case, then we'll write the recursive things, and you will get the previous term. Then we'll take the you can say string builder, so that we can keep adding in the uh, all the strings, and we will return finally. And then we'll take a for while loop or loop to traverse all the previous string, and we'll count the current character, what are current characters, so that we'll check the occurrence. Once this occurrence is ready, we are ready to add into the append, right? And you will have the appending the character followed by the character, right? That we are doing. So what we are doing here, actually we will append the count, and then we'll append the character. You remember we have used first 3 and then 1, so this will be the count. How many characters are there? The 3. and then that is the current character is 1, so we'll whatever 3 ones we will have it, and then we will return it, right? So that's how we solve the count and say problem using the recursion and the length encoding. So if this help you, give it a thumbs up and subscribe this channel. And if we'll talk about the time complexity and space complexity, so if you see, observe here, we are going through n cross m, because n is the number of inputs here, and m is the average of the length, right? Because we are going through n cross m, right? Total number of inputs will be there, so we'll go through all the inputs, we'll get the length of the string, what is the length of a string, till that it will go, and so we can say m cross n is the exponentially it grows with a string, okay? And for the space complexity, O of n, number of characters, so you can say length of the string is the count for the adding the string, right? For each recursion level, you can say, right? And so if you like this video, please give a thumbs up and subscribe this channel for more DSA content. Drop a comment if you want the iterative version of this problem or any other problem that you need to be explained. So thanks for watching, guys. I'll see you in the next one, and I'm signing off. Thank you.